Friday. Welcome to the Tejano Virtual Events Happy Math Hour, our weekly interactive math reviews for Math 1314 and Math 1324, presented by Yvette Chuca, Ruben Carizales, and Albert Isasi. Our session will be starting soon. This session will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's event will be able to come and watch it later. Thank you. So now at this time, please mute your mics for best sound experience. Otherwise, the feedback could interfere with information we will be sharing.
Hello, everyone. Welcome to Friday Happy Math Hour. So they just placed the link in the chat. If you're in 1324, you want to go ahead and go to that room. Otherwise, we're going to start with 1314. So in this presentation, we're going to be looking at basic matrix operations and using the matrix operations. And so this presentation, if we have time, then I'll go back to chapter 7 information as well. Okay. At any time, if you want to download the PowerPoint, you'll be able to, and I'll show you how in a little bit. Okay. So for section 8.1, oops, let me put the file back up. Let me just get to the, scroll down to the page. Okay. Okay. So for section 8.1, we're going to be looking at matrices and how we can use them to solve systems, which your systems we looked at in chapter 7. And if you recall in chapter 7, you could solve a system by graphing or doing the substitution method or the elimination addition method. Okay, so basically what is a matrix? So a matrix is just a rectangular array of numbers. And inside of the matrix, we have what we call elements. So every number inside the matrix, these are called elements. Okay, so the definition of a matrix, again, your matrix is made up of rows and columns. The rows are going to be the ones that go horizontally, and the columns are the ones that go up and down, so vertically. And if you notice here inside, we have what we call the elements. You'll see them as numbers. But with these elements, you have two little numbers next to them, and that just tells you their location. So, for example, the A11 is telling us that it's located in the first row, first column. If we look at the A32, that's telling us that it's located in the third row, second column. To determine how big a matrix is, or to give the size, another word for size is order. We use the number of rows by columns. So in this example, we would have m rows and n columns. Okay, so here we have what we call a square matrix. A square matrix basically has the same number of rows and the same number of columns. So here we would have 2 rows. So this is 1, 2, and then columns are 1, 2. So we have a 2 by 2 matrix. In this next example, we only have 1 row, but we have 2 columns, 1, 2. So this is a 1 by 2 matrix. Since it only has 1 row, we call it a row matrix. And then the third one is a column matrix, and we call it a column matrix because there's only 1 column. So if you notice here, we have 1, 2 rows, and then the 1 column. The fourth matrix is a square matrix as well because it has 2 rows and 2 columns, but this is also called the identity matrix. Your identity matrix is a matrix that has ones in the diagonal. So this is our diagonal. And then it has zeros everywhere else. Okay. So let's look at this example. I have some matrices on the left side, and then I have the size of the matrix on the right side. So here we're just going to try to match them. Let me go back. Okay, so let me get the pencil out so we can match them. And so the first one here would be how many rows? We only have one row. And how many columns? We only have one column. So this is going to match with a 1 by 1. And then the second one, we have one row. And then we have 1, 2, 3, 4 columns. So that's going to be a 1 by 4, which is right here. And then the third one, which is actually has a name. If it's zeros everywhere, we call it a zero matrix. And so here we have 1, 2 rows, and then we have 1, 2 columns. So this is a 2 by 2. So that's going to be letter B. And then the last one, we have 1, 2, 3 rows and 1, 2 columns. So that's going to be letter D. Okay, so that is how we identify how big a matrix is. So let's go to the next one. So here we have something called an augmented matrix. An augmented matrix is going to be made up of transferring it from a linear system. And so the augmented matrix is made up of coefficients, and it's also made up of constant numbers. Okay, so if you look at this linear system here, you have x's and you have y's, and then you have your -9. So the 3 and the 5, those are what we call coefficients, and then the -9 is your constant. So we would simply write our coefficients, 3 and 5, and then we have our -9. This vertical line, you could think of it as the equal sign. And then the second equation is a coefficient of 1 for x, a coefficient of 4 for y, and then we have a -10 as our constant. So this is our augmented matrix. So it says write the augmented matrix for this linear system and what is the dimension. Okay, so we have x is 1, y is 3, w has a -1 in front, and then our constant 9. Anytime that you're missing one of the variables, then we would use a 0. Okay, so here we have 1, 3. Notice that I have a z in here, so I'm going to have 0 for z. And then we have our w, which is -1, and our constant 9. Then for the next one, we don't have an x, so I use 0. Then y is -1, z is 4, w is 2, and our constant is -2. And then the third one, in front of x, I have a 1. There's no y, so I use a 0. And then z is -5, and w is -6, and my constant is 0. Then we have 2 for x, 4 in front of y, -3 for z, and then I don't have a w, so I use 0. And then my constant is 4. So we want to get the dimensions. So the word dimension is just another way of asking for what is the order. In other words, what is the size. So if you see the words order, size, or dimension, they are all the same. So in this case, I have 1, 2, 3, 4 rows, and I have 1, 2, 3, 4, 5 columns. So my dimension or my order or the size is a 4 by 5. If you have any questions at any time, feel free to just let us know. So let's go to the next one. So it says write the system of linear equations represented by the augmented matrix. So now we want to go from the blue to the system of equations. Okay, so here the first number is a 6. So that means that that's the coefficient for a variable x, and then the 5 is a coefficient for a variable y. Then I have my vertical line, so that means I have an equal sign, and then our constant is 2. Okay, so we're going to have 6x plus 5y equals 2. And then the second equation is 3x minus 9y is equal to 0. And that would be your answer. Okay. It says write the system equation as represented by the augmented matrix. So same idea, they want us to do what the system is. So here I have a 1. So that's the coefficient for x. I don't have a y. And then my vertical line is here in the middle. And then I have 4. So this system can be translated as x is equal to 4 and y is equal to 3. So in our goals right now, our goal is going to be to take a system and write. If you're not able to see the presentation, you might need to log off and come back in, unless there's more people that aren't seeing it. Okay, so can you just let me know if you're seeing it, somebody else, just to be sure? Like Ms. Enriquez or Nikki, do you guys see my presentation? Okay, so yeah, so just log off and then come back in. All right, thank you guys. Okay, so our goal is going to be to take a system, and on the left side, if we can write it as 1, 0, 0, 1, then we can get our solution for x and y if we can only write it this way. Okay, so that's going to be our goal. So how are we going to get to our goal? In order to get there, these 3 operations are going to help us. So when you're working with a matrix, you can switch rows, you can interchange them. You can multiply a row by any non-zero constant. You can add a row to one another or a multiple of a row. So let's practice. So let's practice with some of those here in a little bit. So the process to arriving to our goal. So I give you a system of equations. That's this one here. We're then going to write it to an augmented matrix, which is this one here. And then we're going to use order of operations, which we have 3 that we could use. And then hopefully by that time we end up with a matrix that has a 1 in the diagonals and 0 everywhere else, which is our identity matrix. And then from here we'll be able to say that x is equal to 4 and y is equal to 3. Now this process of doing this is going to is called the Gaussian elimination method. And what our goal is to take this matrix and write it in reduced echelon form. Okay, so let's see if we can just look at these operations. So it says interchange the first and second rows of the matrix. So that's probably the easiest operation, because all we're doing is we're just rewriting the original matrix by switching the 2 rows. So my first row here, 0, 1, 3, 4, I'm going to write it as my second row, 0, 1, 3, 4. And my second row, I'm going to write it as my first row, so negative 1, 2, 0, 3. So that's how that interchange of rows works. The next one is multiply the first row of the original matrix by a half. The symbol for that is 1/2 times row 1. So R1 just stands for row 1. And then you're going to see an arrow. The arrow means that we're just going to put it back into the first row here. Okay, so this is my symbol here. We're going to take 1/2, multiply it times row 1. Whatever answer you get, you're going to place it back in row 1. Okay, so if I have 2 here and I multiply it by a half, 1/2 times 2 is 1. So that's why I have a 1 here. Negative 4 times a half is negative 2. So I put my negative 2 here. 6 times a half is, or 6 times a half is 3. So I'm going to have 3. And then negative 2 times a half is negative 1. Okay. And then the last one is we can add negative 2 times the first row of the original matrix to the third row. Okay, so let me just translate this symbol here. It says multiply negative 2 times row 1, and then whatever you get, you're going to add it to row 3, and whatever you get there, you're going to place in the third row. Okay, so let me get my pencil out so I can I can walk, or I can circle the steps as I'm going. Okay, so here it says multiply the second row let's see, it says add -2 times the first row. I'm sorry. So 2 times the first row. So I have 2 times 1 is 2, right? And then we're going to add it to the third row. So 2 times 1 is 2 plus 2 is 4. Okay, so let me go ahead and, oh, it's a -2. So that's important, right? Let's follow our, make sure we have our right sign. So let's start over. So -2 times 1 is -2 plus 2 is 0. So notice here I put a 0 in this location. And then we go to the next one. -2 times 2 is -4. And then we're adding it to the third row, which has a 1. So -4 plus 1 is -3. So I place my answer in the matrix. And then we go to the next one. -2 times -4 is +8. We're going to add it to the 5. So we get 13. 8 plus 5, 13. And then -2 times 3 is -6 plus a -2 gives me the -8. Okay. So these are the operations that we're going to be using. And let me go ahead to the next one so we can actually try an example. So here it says use matrices to solve the system. So remember our process, right? So we're going to take our matrix right here, and our goal is to get to a matrix that looks like this. And so here's my matrix. And so let me just go back really quick. I always recommend to my students to always start with this number here, and always try to make that a 1 always. That's where you should have your starting point. Once you have a 1 there, then you make anything below it a 0. Okay. And then once you have zeros below it, then you go to this one here and you make that a 1. And then you use that one to make everything above it zeros. If you don't follow this process, then you might be changing and going around in circles, which could lead to frustration. Okay, so always, let me go ahead and write up here our goal so that we can see it. Okay, so my question here is, do I have a 1? Since my goal needs a 1 here, do I have a 1 here? And the question is I don't, right? So I need to make that to a 1, and there's 2 ways to do that. Number 1 is I can multiply the 2 by a half, and that would make it a 1. But if we look below it, there's a 1 there already. So what I could do is just switch my rows. And so this symbol here means take row 1 and switch it with row 2. So now I'm going to write it as 1, -1, and 5, 2, 4, and 8. So now I have a 1 here. So I have a 1 here. That was what I wanted. So now I need to make everything below it a 0. Okay. In order to make it this number 2 a 0, you want to multiply the 1 by its opposite number. So if it's a +2, you're going to multiply the 1 by a -2. And then we're going to add them together. And -2 plus 2 will make it become a 0. Okay, so let's go ahead and do that. So we're going to multiply -2 times row 1. And then whatever I get, I'm going to add it to row 2. And since I'm trying to make this a 0, I'm going to place my answer in row 2. Okay, so here's my -2. So I go -2 times 1 is -2 plus the 2 is going to be 0. So I put my 0 below that. But we can't just do it to one number and be done. We need to do it all the way across. So the next one is going to be -2 times -1 is +2. Then we add it to the 4 and we get a 6. So we write our answer below the -1. And then the last one is -2 times 5 is -10 plus an 8 equals -2. Okay, so far in our goal, we have our 1 and we have a 0. So now my next goal is I want to make this 6 a 1. Okay, so in order to make the 6 a 1, I can multiply the 6 by a 1/6. Some people like to say I'm going to divide by 6, but in matrices, the operation is multiplication. And so we're going to multiply by 1/6, which is essentially the same as dividing by 6. Okay, so let's go ahead and write that. So I'm going to take 1/6 times the second row, and I'm going to put it in the second row. So I have here 1/6 times 0 is going to be 0. 1/6 times 6 is going to be 1. And 1/6 times -2 is going to be negative 1/3. So this is what we have. So 1/6 times 0 is 0. 1/6 times 6 is 1. And 1/6 times -2 is negative 1/3. Notice that the top row, I did not do anything to it. I just left it as it was since I was trying to change the second row. And so now our goal is getting closer and closer. I have my 1, I have my 0, I have a 1. So now I'm going to use the 1 to make it a 0. In order to do that, they have to have opposite signs, which they do. So all I have to do here is add -1 plus 1, and that would give me my 0. So in symbols, we would write row 2 plus row 1, and whatever answer we get, since we're trying to change the first row, we're going to place it back in row 1. So we get 0 plus 1 is 1, 1 plus -1 is 0, and negative 1/3 plus 5 is 14 thirds. Okay, so let me write that on the side so we can see how we got that number. So we have negative, oops, let me get my pen out again. So we have negative 1/3 plus 5. In order to add these, I need a common denominator. So this one stays the same, negative 1/3. And in order to make this has a 1 below it, right? 5 divided by 1 is 5. So I need to multiply this by 3 divided by 3. So that becomes 15. 5 times 3 is 15. And now 15 plus -1 is 14 thirds. Okay, so that's how we got 14 thirds. And then the second equation stays the same because we weren't trying to change that one. So this one stayed the same. So now notice on the left side, I have my identity matrix. I have the 1s and the 0s. So if I change it back to a system, I'm going to have x is equal to 14 thirds and y is equal to negative 1/3. So you might be asking yourself, well, didn't we solve these systems using other methods in chapter 7? And maybe you feel more comfortable with those methods. And the answer is yes, you can use those chapter 7 methods, or you can use the chapter 8 methods. But as things get larger and larger and larger, then the matrices become more helpful. And in fact, of course, if you are working with 3 variables or 4 variables, then a calculator would be helpful. And if you're working with hundreds of variables, then a computer would be helpful. So we're just trying to give you an understanding of the different ways that these can be solved. If we have time, I'll show you how to use the calculator as well, in case your instructor lets you use the calculator. So let's try this one here. We have a system, and we're trying to get to our goal again. So here, I cannot switch my rows, right? Because if I switch my rows, it's not going to help me. So I'm going to look at this -3. How can I change the -3? So if I multiply it times a negative 1/3, then it will become a 1. So I'm going to multiply negative 1/3 times row 1. And then I'm going to put it back in row 1. Okay, so I have negative 1/3 times -3 becomes a positive 1. Negative 1/3 times 4 becomes a negative 4 thirds. And negative 1/3 times 22 becomes a negative 22 over 3. Okay, so now I have my 1, so that makes me happy. Now I need to make my 6 a 0. So how am I going to make that 6 a 0? Remember the 1, you multiply it by the opposite of what you see down here. So the opposite of 6 is going to be a -6. So I have -6 times row 1 and then I'm going to add it to row 2 so that it can become 0. And then I'm going to put my answer back in row 2. So this little double arrow should really just be an arrow pointing to the right side, okay? Because we're not switching anything, it's just an arrow pointing to the right side. So let's go ahead and do the work. Since I'm trying to change that second row, I'm not even going to do anything to the first row, so I just went ahead and I just wrote it out, okay? So now we can do the multiplication. -6 times 1 is -6, okay? Plus 6 is going to be 0. And then -6 times -4/3 is going to be a positive, or let me go to the next slide. Okay, here we go. -6 times -4/3 is going to be a positive 8. And then -4 gives me a positive 4. And then the next one, -6 times -22/3. And that's going to give me a positive 44. The way I'm getting a 44 is that -6 divided by 3 is a 2, and then 2 times 22 is 44. And then -28 is equal to 16. So I get 16. Okay, so that's how we end up with 0, 4, and 16. So now we have our 4 that we need to make into a 1. So to make it a 1, we can multiply by a positive 1/4 to the row 2 and then place it in row 2. I'm not going to change row 1, so I just copy it over. And then 1/4 times 0 is going to be 0. 1/4 times 4 is going to be 1. And 1/4 times 16 is going to be 4. Okay, so 1/4 times 0 is 0. 1/4 times 4 is 1. And 1/4 times 16 is 4. So we're almost to our goal. So in fact, even here, you already know that y is equal to 4. And so then you can just back substitute to get your x, okay? Okay, so now we're gonna make the -4/3 become a 0. So in order to do that, remember the 1, you have to multiply by its opposite. So its opposite is positive 4/3. So 4/3 times row second, or the row 2, plus the row 1, and then our answer we're gonna place in row 1. Okay, so let me go ahead and do that. Notice I'm not changing row 2, so I just write it as it is. And then we're gonna do the work. So 4/3 times 0 plus 1 is gonna be 1, so I place my 1. And then this next one, 4/3 times 1 is 4/3, plus a -4/3 is gonna be 0. So then the next one is 4/3 times 4. So 4/3 times 4. And then we're going to subtract it with -22/3. Okay. So 4/3 times 4 is the same as 16/3 minus 22/3. And so that's going to be equal to -6/3, which then comes out to a -2. So my solutions here are that x is equal to -2 and y is equal to 4. So again, this is using the Gauss-Jordan elimination. You'll be able to also solve the same system using inverses. And so for some people, they prefer that. And then another method is using determinants, which is from another section in this chapter. So in 8.2, we're going to be looking at how do we add and subtract these matrices, and when do we know if they're equal or the same. And so two matrices are equal if they have the same dimension. In other words, they have the same order, the same size, and they have the same corresponding entries. You can add two matrices together if they have the same order. And then the way we add them is we add the corresponding entries together. And then we're going to have something called scalar multiplication, which means that we're going to take any number and you can multiply it to the matrix. And to do that, you would end up multiplying each element by that number, which we call scalar. And we'll do some examples here in a second. And then two matrices can be subtracted if they have the same order, and we subtract the corresponding entries. Okay. So let's look at this. For the matrices below, find 3 times A. Let's do that one first. So 3 times A just means that we have 3. And then here's my matrix A. So 3 is called your scalar. And so in order to multiply this out, you're going to take 3 and multiply it times each of these numbers that we see in the matrix. Okay. And so if we do that, then we end up with 3 times 2, 3 times 2, 3 times 4. So we end up with 6, 6, 12, negative 9, 0, negative 3, 6, 3, and 6. So that would be our answer here. Negative B is the same as saying negative 1 times the matrix B. So here's my matrix B. So we're going to multiply negative 1 times 2 is negative 2. Negative 1 times 0 is 0. Negative 1 times 0 is 0. Negative 1 times 1 is negative. Negative 1 times negative 4 is positive 4. Negative 1 times 3 is negative 3, and so on. So then we get 1, negative 3, and negative 2. For letter C is 3A minus B. So if I always find it easier to rewrite it using the actual matrix. And so here we're going to have 3 times A, which we figured out was this matrix over here. So that's 6, 6, 12, negative 9, 0, negative 3, 6, 3, 6. And then we have B, negative B, which we also figured out here. And so I'm taking this matrix plus this one. And in order for me to add, they're both 3 by 3. So yes, I can add them. So to add them, we would take the 6 plus the negative 2 is a 4. And then 6 plus 0 is 6. 12 plus 0 is 12. Negative 9 plus negative 1 is negative 10. 0 plus 4 is 4. Negative 3 plus negative 3 is negative 6. 6 plus 1 is 7. And then 3 plus negative 3 is 0. 6 plus negative 2 is 4. And so that's how we would add corresponding entries. Okay. So for the next one, A plus B, I'll give you about 30 seconds to see if you can figure out what A plus B is really quick. Okay, so first we want to check, can we even add these, right? Because if the order is not the same, then we are not going to be able to add. So this order here is 2 rows and 3 columns. And then for letter B, we have, so this one is 2 by 3, and this one is 2 by 2. So if you notice, the orders are not the same. So we cannot add this, okay? So it says, if not possible, enter impossible. So our answer is impossible. Now here, I wanted to take a picture of this screenshot because one of the questions I get asked a lot is, I'm trying to enter my answer, but the matrix is too big or it's not big enough. So how do I adjust it? So if you see these little green arrows here, if you click on them, you can add or delete rows or columns. So this is how you adjust the size of the matrix. Okay. So I believe the following things are what I just mentioned. So let's go to the next slide here. It says solve for X and Y. Okay. So here, all we know is that this matrix is equal to this matrix. So we have, how do we know that they're equal? Because the equal signs is here. That means that whatever I see in this side, negative 4, should be the same thing on this side. And if I have a 6, it should be the same thing here. So here I have X is equal to negative 3. So that means that X is going to be negative 3 and 21 is equal to Y. So that tells me that Y is 21. Okay, so this one was okay. It was there was no adding or subtracting that we had to do. Over here, we have 18, 18, we have a 5 and a 5, and then we have x and 2x plus 5, and then we have our 2 and our 1, I mean our 2, and 1, 1, 2, 16, 5y minus 4, and 1 and 1. So what I can do here for my x, I can say that x is equal to 2x plus 5, and I can say that 16 is equal to 5y minus 4. And so now I just have an equation, and I can solve for x. So here we're going to have, if I subtract negative 2x on both sides, I get negative x is equal to 5 divided by negative 1. So we get x is equal to negative 5. And then for the second one, if I add 4 on both sides, I get 20 divided by 5. So I get y is equal to 4. So here it says solve for x in the equation where A is this information and B is this matrix. Okay, so let's set it up. So here I have x is equal to 2 times A, so here's A, plus 2 times B, here's B. So first I'm going to multiply the 2 into this matrix. So 2 times negative 3 is negative 6, 2 times 2 is 4, 2 times 3 is 6, 2 times negative 2 is negative 4, 2 times 0 is 0, 2 times 4 is 8. And then 2 times 3 is 6, 2 times 2 is 4, 2 times negative 5 is negative 10, and 2 times 5 is 10, 2 times 0 is 0, 2 times 3 is 6. So now if I check the order, this is a 2 by 3, and this is a 2 by 3, so yes, I can add them. So I get negative 6 plus 6 is 0, 4 plus 4 is 8, 6 plus negative 10 is negative 4, negative 4 plus 10 is 6, 0 plus 0 is 0, and 8 plus 6 is 14. Okay, so then we would enter our answers into the boxes there. Okay, so this is a different one. So we have 4b and we're trying to solve for x. So first we can take this equation and just solve for x. So I'm going to add 2x on both sides. So I get 2x, and I'm going to subtract 4b on both sides. So I get 2x is equal to negative 2a minus 4b. And then to get the x here, I'm going to divide by 2. So I get x is equal to negative 2 divided by 2 is negative a, and negative 4 divided by 2 is negative 2b. And so now that I know what x is, I can just write down our matrix. And so here I have a negative 1 times the matrix A, which is here, minus a negative 2 times the matrix B. So multiply the negative 1. Negative 1 times negative 2 is positive 2. Negative 1 times 1 is negative 1, and so on. So we end up with 1, 0, negative 4 in the second row. And then we do the same for this second matrix. Negative 2 times each of these elements will give us 0, negative 4, or positive 4, negative 6, 0, and negative 6. My order, just double checking, is 2 by 3, 2 by 3, so I can add them. So 2 plus 0 is 2. Negative 1 plus negative 4 is negative 5. Negative 1 plus 4 is 3. 1 plus negative 6 is negative 5. 0 plus 0 is 0. And then we have negative 4, negative 6, negative 10. Okay, so how do we multiply the matrices? So previously we were talking about adding, subtracting. In order to be able to multiply two matrices, you want to look at the order. So for this matrix A, the order is M by N, and for this matrix B, the order is N by P. In order to be able to multiply, the number of columns in the first matrix has to be the same as the number of rows in the second matrix. In other words, these inside numbers have to be the same. The outside numbers tell you how big your product's going to be. So after you multiply A times B, you should end up with a M by P matrix. Okay, so let's check it out. So I have this 4 by 1, 4 and 1, 1 and 2. So my order here is 1 row, 2 columns. This one has 2 rows and 1 column. The inside numbers here are the same. So that means that I can multiply. And after I multiply, I'm going to end up with a 1 by 1 matrix. Okay, so this is going to be our result, 1 by 1. So how are we going to multiply? We're going to take the first number times the first number here. So 4 times 1 is 4. And then we're going to add it to the product of the second number times the second number. So 1 times 2 is 2. Okay, so 4 times 1 plus 1 times 2 is going to be 6. And so that would be your answer here. Okay, let's check the second one. You have 2 rows and 1 column. This has 1 row and 2 columns. The inside numbers, they're the same. That means yes, we can multiply. And the outside numbers is how big the matrix is going to be. So how are we going to multiply? We're going to take the first row. So you want to look at the first row times the first column. So that's 1 times 4. And I'm going to place it here. And then you go to the next column. 1 times the next column, which is 1 times 1. And that one goes here. There's no more columns, so we go to the second row. So now we're looking at the second row. So 2 times 4 is going to be down here. And then we go to the next column. 2 times 1 is going to be here. So if I multiply those out, 1 times 4 is just 4. 1 times 1 is 1. 2 times 4 is 8. And 2 times 1 is 2. So this is my result. Okay, find a squared where a is equal to that matrix. So a squared is just a times a. And so I can write it as, I'm not just write the matrix out. We'll look at the orders, 2 by 2, 2 by 2. The inside numbers are the same, so that means yes, I can multiply. And the outside numbers tell me how big my result is going to be. So to do the work, we're going to look at this first row. If you notice, I have a brown line that I'm highlighting this first row. So it's this first row times the first column. So the first number times the first number is 3 times 3 plus 1 times -1, and that's going to be in this first position. And then I go to the next column. So I have my arrow pointing. So it's going to be 3 times 1 plus 1 times 2, and that's going to go here. There's no more columns, so now I can go to my next row and do the same, -1 times 3 and 2 times -1. Then we go to the next column, -1 times 1 and 2 times 2. So if we simplify, 3 times 3 is 9 plus a -1. 3 times 1 is 3. 1 times 2 is 2. So I'm just multiplying these numbers out. -1 times 3 is -3. 2 times -1 is -2. -1 times 1 is -1. 2 times 2 is 4. 9 plus -1 is 8. 3 plus 2 is 5. -3 plus -2 is -5. -1 plus 4 is 3. Okay, let's try this one. So I have my B and my A. B is 2 by 2. A is 3 by 2. Notice that the inside numbers are not the same. So the answer is that it's impossible. So we cannot multiply. Okay, so that was multiplication of matrices. The inverses, we kind of talked about this a few minutes ago. And so we have a 2 by 2 identity matrix. The identity matrix, remember that the diagonals here are going to be ones. Everywhere else is zeros. A 3 by 3 diagonal or 3 by 3 identity matrix is ones on the diagonal and zeros everywhere else. And if you take any matrix times its inverse, it should give you the identity matrix. If you flip it around, it's still going to give you that identity matrix. And the symbol is this little -1 on top. So it says show that B is the inverse of A. If they're inverses, if we multiply these together, A times B, I should get the identity matrix. Or if I flip it around, B times A should also give me the identity matrix. Okay, so if we multiply -1 times 1, and then 2 times 1, we get -1 plus 2, which is 1. And then if we go to the next one, -1 times -2 is +2. 2 times -1 is -2. And then we go to the next row, -1 times 1 is -1. 1 times 1 is +1. Go to the next column, -1 times -2 is +2. 1 times -1 is -1. If I simplify, -1 plus 2 is 1. 2 minus 2 is 0. -1 plus 1 is 0. 2 minus 1 is 1. So if you notice here, A times B gives me that identity matrix. And that's a good step. But in order for them to be inverses, B times A also has to give you the identity matrix, which it does. Since I get the identity matrix for both, then I can say that they're inverses of each other. Okay. So how do we find the inverse? There's different ways of finding the inverse. You can use this method here, where you take your matrix and you attach the identity matrix. Then you use row operations so that you end up with the identity matrix first, and then whatever's left is the inverse. There's a formula that you can use if you have a 2 by 2. But if you have a 3 by 3 or higher, then you would have to use this method here. And then there is a different method, which is this one here. And this one is kind of using chapter 7 methods. And I think for today, we're going to focus on the first two. Okay, so it says find the inverse of A. So here's your matrix A. So the first step is we're going to attach this identity matrix, so the 1, 1, 0, 0. And then we're going to use row operations so that we can end up with 1, 1, 0, 0 on the left side. Okay, so let me click to the next slide. I want to make sure I have a 1 here, which I do. And then now I need to make whatever's below the 1 a 0. So I'm just going to add these two. 1 plus -1 would give me a 0. So that's what I have here. Row 1 plus row 2. And then our answer, we put it in row 2. Okay, so 1 plus -1 is 0. 4 plus -3 is 1. 1 plus 0 is 1. 0 plus 1 is 1. I didn't change the first row. I just rewrote it. Now I want a 1 here, which I have, so that's good. So let's make this 4 a 0. So in order to make the 4 a 0, remember you multiply the 1 by its opposite. Since I have a +4, the opposite would be a -4. So I'm going to multiply -4 times the second row. I'm going to add it to the first row, and whatever I get, I'm going to place it back in the first row. Okay, so -4 times 0 is 0, plus 1 is 1. Okay, and then -4 times 1 is -4, plus 4 is 0. And then -4 times 1 is -4, plus 1, -3. And -4 times 1 is -4, plus 0 is -4. So notice now you have 1s here and 0s here, so that's our identity matrix. So whatever we have left on the right side, that's going to be your inverse. So my inverse is -3, -4, 1, and 1. So that's this part here. Okay, so is there an easier way to do this? Yes, you can use the second method. Let me go ahead and let's go to the second method. Actually, let me go back here. So the second method is if you have a matrix, we're going to use this formula here where we're going to have 1 divided by, you're going to multiply A times D minus B times C. We call that the determinant. And then in the matrix itself, we're going to switch the letter A and D. So notice here you had A and D. We switch them. And then for the B and C, we switch the signs. So you have +B, +C. Now you have -B, -C. So if we look at this example, notice this is just A, B, C, and D. So my inverse is going to be, I always like to write the formula down, and it's just substitute these values. So we have A times D, which would be 1 times negative 3, and B times C, which is B 4 times negative 1. Then we're going to switch D and A. So notice here I have A is 1, D is negative 3. So if I switch them, negative 3 and 1, then we're going to switch the signs. So a positive 4 is now going to be a negative 4, and a negative 1 is now going to be a positive 1. So 1 times negative 3 is negative 3. Negative 4 times negative 1 is positive 4. And we keep simplifying. So we get 1 divided by 1, which is going to be 1 times the matrix is going to be itself. And so that's going to be your inverse. If you happen to get a 0 in the denominator here, that just tells you that there's no inverse. Okay, let's try another one. Okay, so let's do the first one here. I'm going to use the formula. So we have 3 times 2, and then we have negative 1 times negative 2. So that would be here. Then I'm going to switch my 3 and the 2, so I get 2 and 3. And then I'm going to switch the signs from negative to positive, so we have positive 1, positive 2. If we simplify, 3 times 2 is 6. Negative 1 times negative 2 is positive 2. So 6 minus 2 is 4. So I get 1/4 times the matrix. Multiply it times each of those numbers. So 1/4 times 2 is a half. 1/4 times 1 is 1/4. And 1/4 times 2 is a half. 3 times 1/4 is 3/4. And then the second one, I'll let you, if you guys download the PowerPoint, then I will go ahead and let you guys look at it. On the right side of your screen, you should see a box with an arrow pointing down. If you click on that, it will let you download the PowerPoint. Okay, so let me see. Here's right below my my blue arrow. That way I can get to an example solving the system. Just really quick here, notice you got a 0. So that just means that you have no inverse. Okay. So how do we use the inverse to solve a system? And the way we're going to do that is we're going to take our solution is going to be equal to the inverse times b. So let me go here. So use the inverse matrix to solve the system of linear equations. Okay. So here from this solution set or from this system, you need the augmented matrix, which is just the coefficients. We're going to call it the coefficient matrix. So we have 1, negative 3, 3, and negative 8. And then we're going to have a constants matrix, which is 4 and 12, 4 and 12. And then we have a variable matrix, which is x and y. So the formula is that your x here represents your variable matrix. Then you're going to have your inverse and then your b. Now, A is here because you need to find the inverse. And to save time, they already tell me what the inverse is. So I'm going to take my inverse and I'm going to plug it in here. I'm going to take my constants and plug it in here. So all I have to do now is just multiply them. So negative 8 times 4 is negative 32. 3 times 12 is 36. If I add that, I get 4. And then negative 3 times 4 is negative 12. 1 times 12 is 12, so I get 0. So that tells me that x is equal to 4 and y is equal to 0. Okay, so, but in some of your homework, you're not going to be given the inverse, so we have to find it. So when you have something like this, solve the system using the inverse matrix, then I recommend that you write down the A, which is 1, negative 5, 5, negative 24, and then your constants, 27 and 128, and then your variables, x and y. So here it says to find the inverse. So in order to find the inverse, I'm going to use the formula. So I have 1 divided by A times D, so that's 1 times negative 24, minus B times C, which is negative 5 times 5. Remember, we switched the A and D, so I get negative 24 and 1. And then I switch the sign, so instead of negative 5, I have 5. And instead of a positive 5, I have a negative 5. Simplify. So this gives me 1 times negative 24 is negative 24. Negative 5 times 5 is negative 25. Negative 24 minus negative 25 would be a 1. So this is going to be my inverse here. And so now I can plug it into our equation here. So I have my variables is equal to my inverse, which I just found here, and then our constant. So to find the answer, we're going to multiply these two matrices. So to multiply, we're taking, let me get my pencil. We're looking at this row with this column, and then we'll look at the second column as well. Oh. Okay, so we're going to have negative 24 times 27 and 5 times 128. Okay, so negative 24 times 27, 5 times 128. And then we go to the second row, negative 5 times 27 and 1 times 128. And so if we do the multiplication here, then we end up with negative 8 and 7. Okay, so we get x is equal to 8, x is equal to negative 8, and y is equal to negative 7. Okay, and so here we have another example. It's set up the same way. Okay, here you have your a, which you don't really need. You don't really need, so because they already give you the inverse. And then your b is 0.63. So if we set it up, we would multiply the inverse times 0.63, and then we just multiply across. Okay, so again, we're not going to have time to find the determinant, but basically for the determinant, you're just finding that first part of the inverse when we do the formula. Let me go back. So remember that determinant is down here. Okay, so if we come back, we're multiplying a1 times b2 and b1 times a2. So it's this times this and this times this. The symbol for determinant is this, it looks like the absolute value sign, or these two little vertical lines, or sometimes they write it as dt parentheses a. Okay, so I guess we have time to do a couple of these. So 2 times 2 and negative 3 times 1. So we get 2 times 2 and negative 1 times 3. So we end up with 4 plus 3 is 7. And then the next one is 2 times 2 and then minus 4 times 1. So we end up with 4 minus 4 is equal to 0. So here the determinant is 0. That tells us that there's actually no inverse if we were trying to find the inverse. So 0 times 4 and then 2 times 3 halves. So we end up with 0 minus 3 is negative 3. Now to find the determinant of a bigger matrix, we definitely have no time for that. But just really quick, you would take your first number or your first row, first column, and cross it out. And then you find the determinant of this little piece here. And you do that all the way across. So now I cross out this one, and I find the determinant of the numbers that are remaining. And we keep doing that for each one. And then you start crossing out the second one, and you take all the different possibilities. Okay, and then you end up with these numbers. Then we have to take the cofactors, and we're basically going to change the signs there. Negative 1 times a positive is a negative 1. Negative 5 times negative is a positive 5. And so this is a little bit longer than the other way, right? So at this point, if your teacher lets you use a calculator, then you could use a calculator and find the determinant. If you were looking at the chat, they put some links to the YouTube channel. So if you go back to some videos in the spring, I believe I have some videos in there where I showed a glimpse of the calculator. Or you can email me, ichuka@epcc.edu, and I'll be happy to send you a quick video on how to use your calculator for these if you have, that is if your instructor lets you use the calculator. But I think that's all the time we have, so I encourage you to download the presentation if you would like to see the rest of the slides. There's only 10 slides here, but remember that I started this at slide 92. So from slides from 1 through 91 are from chapter 7. So if you need help with chapter 7, those cover the chapter 7 sections. And I'll pass it back over.
Thank you, Ms. Chuka, for your presentation. If you would like to download a copy of the presentation, again, you can go right here to where I have the pointer to the top right corner and click on the box with the arrow going down while the presentation is on the screen. We do want to remind you all about the previously recorded sessions, which are available on a YouTube playlist. This session will also be available on that playlist later today. And also linked is a short survey to help us improve our TVE sessions. Please take a few minutes to fill out that survey. Before you all leave, I want to share the TVE sessions that we will have next. So next week at 1 p.m., we will have a presentation by the EPCC Mental Health Committee. And at 3 p.m., we will be back with Happy Math Hour, where both Math 1314 and Math 1324 will cover the final exam reviews. Thank you all for coming in today. We hope you all have a lovely weekend. If you have any questions, feel free to use the chat box or your mic. We hope to see everyone again for Happy Math Hour.